We're here in David Armstrong's field where we're starting to harvest our net zero trials. This is the second year of a 3-year Innovate funded project where we're looking at the carbon footprint of growing, transport and storage of potatoes. We've gathered data from our growers that have highlighted the key areas of carbon and CO2 emissions and the relative size to the proportion of the crop. Growing the crop is equivalent to 5 litres, fertiliser and chemicals 22 litres, storage is 8 litres and diesel usage is 9 litres. So this has helped us focus our work on how to carry out the trials. Here in the net zero field we're focusing on the soil, the biology, the nutrition, the diesel usage and cultivations that's involved, and also the carbon emissions that actually come out from the soil. We're trying to find the right balance of reducing inputs and cultivations, but crucially that won't adversely affect the yield or the quality of the crop. Before the crop was planted, Dr. Ian Gould from the University of Lincoln took soil samples from the field so that we could understand the baseline nutrition and also assess the health of the soil. He took soil cores down to 90 centimetres to establish the nutrition of the soil, but also the moisture and the temperature of the soil. The trials were planted in the field following an overwintered cover crop. Within the cultivations trial, we've looked at different levels of cultivations, low, medium and high intensity. We expect to see the less that we move the soil, then the less CO2 is released from the soil and protecting soil structure and microorganisms within the soil. The most intensive cultivation was ploughed, then cultivated, before going through with a power ridger, de-stoner and then planting. In contrast, the low intensity, we went straight in and ridged the soil before de-stoning and planting. The University of Lincoln is studying how the microorganisms in the soil are affecting the gaseous release from the soil. These microorganisms break down the organic matter in healthy soil and provide nutrition to the crops. With the cultivations, we've monitored the diesel usage of each and every machine very accurately. We're also looking at novel ways of planting potatoes with minimum to no soil disturbance, planting under straw, but then also planting on the flat by making small boreholes where we want to plant the potatoes. We've planted crops with varying levels of fertiliser, establishing a baseline with no fertiliser, to then moving all the way up to standard levels of nitrogen. As well as the levels of nitrogen, we're also looking at novel, organically derived fertilisers. We're also trialling different varieties to see how different varieties perform at low levels of nitrogen. Throughout the growing season, we've been assessing these crops and we're starting to see some really distinct differences between the different trials. We've been using the Paquita equipment to carry out in-field leaf analysis that's really given us the nutrient levels of the crop at that moment in time. This allows us to feed the crop what it needs when it needs it without having to send samples off to the lab for analysis. We've also been looking at foliar applications of fertiliser to understand how much nutrition we can get into the plant whilst the plant is growing. We've also been working with a novel technology, R-leaf, which converts NOx gases in the air into nitrate that the plant can then use. Throughout the growing season, the University of Lincoln have been visiting the field, recording the CO2 and NOx gases that have been released from the soil. We'll carry this work on through the harvest process and even post-harvest to understand how this gaseous emission comes out of the soil. It's the first time that this study's been carried out at field scale. The trial field has been topped in late August to allow the skins to mature and set. Everything is then being carefully harvested so that we can fully assess the differences between the treatments. We've all been really surprised how well these potatoes that have had no nitrogen, how well they've actually yielded. But significantly, there isn't the percentage of bakers in the crop that we'd require. Whereas at more traditional levels of nitrogen, you can see yields are better, but more significantly, the baker percentage is much higher. When we were planting the cultivations trial, we were really worried that the lowest level of cultivation wouldn't actually grow a productive crop. It has grown a productive crop, but we need to see how much diesel we use at harvest to get it out of the ground. The highest yielding crop is actually the medium cultivations, which just demonstrates that in this particular field, we didn't need high levels of cultivation. With the small variety trials, we use a very different harvester that literally sieves the potatoes out of the ground. They're then collected by hand before then carrying out a lot of analysis on them to see how they've yielded, what their quality's like, and ultimately how they've performed at the low levels of nitrogen fertilizer and how this has impacted their carbon footprint. As these trials have been harvested, as they go through the harvester, the Harvest Eye unit actually captures the number and the size of potatoes, and that GPS locates it to a point in the field so that we can see the variation quite clearly of how the different plots have performed. We're harvesting into bulk trailers here. These bulk trailers then go back to the yard where they go through the grading process. During the grading process, they'll go over a sizing screen that will take out the very small potatoes, and then they'll go through a visual inspection where we can take out any clods or any stones, any rots and any green potatoes, so that we're only storing the product that's going to be able to be sold. So once we get all this crop harvested, we've got a lot of analysis work to do to understand how each treatment has affected the carbon footprint. We'll then follow this crop through the storage phase and refine our trials ready for next year.